Hi, my name is Felicia Woods. I am a student at Valdosta State University in the class of medicinal chemistry. My project is about proton beam therapy. Here is an overview of my presentation. First is the description, application, comparison with other treatments, costs, and lastly, treatment centers. Proton therapy is a type of external beam radiotherapy that uses ionizing radiation. In proton therapy, medical personnel use a particle accelerator to target a tumor with a beam of protons. These charged particles damage the DNA of cells, ultimately killing them or stopping their reproduction. Cancerous cells are particularly vulnerable to attacks on DNA because of their high rate of division and their reduced abilities to repair DNA damage. The figure to the left describes the different parts of a proton beam. The wobbler magnet rotates the beam. The scatterer spreads the beam. The ridge filter alters the width of the Bragg peak. And the range shifter adjusts the range by absorption. To treat tumors at greater depths, the proton accelerator must produce a beam with higher energy, typically given in eV or electron volts. In most treatments, protons of different energies with Bragg peaks at different depths are applied to treat the entire tumor. These Bragg peaks are shown as thin blue lines in the figure to the right. The total radiation dosage of the protons is called the spread out Bragg peak, or SOBP, shown as a heavy dashed blue line in the figure to the right. It is important to understand that while tissues behind or deeper than the tumor receive no radiation from proton therapy, the tissue in front of or shallower than the tumor receive radiation dosage based on the SOBP. Physicians use protons to treat conditions in two broad categories. The first category is disease sites that respond well to higher doses of radiation. In some instances, dose escalation has demonstrated a higher probability of cure than conventional radiotherapy. The second broad class are those treatments where proton therapy's increased precision reduces unwanted side effects by lessening the dose to normal tissues. In these cases, the tumor dose is the same as in conventional therapy, so there is no expectation of an increased probability of curing the disease. Instead, the emphasis is on reducing the integral dose to normal tissue, thus reducing unwanted effects. The figure at the right of the page shows how beams of X-rays, left frame, and beams of protons, right frame, of different energies penetrate human tissues. A tumor with a sizable thickness is covered by the spread out Bragg peak, SOBP, shown as the red line distribution in the figure. The SOBP is an overlap of several Bragg peaks, blue lines, at staggered depths. The difference between the X-ray therapy and proton beam therapy is the width of the SOBP, depth of the tumor, and the number of beams that treat the tumor. Since X-ray treatments are usually done with multiple exposures from opposite sides, each section of skin is exposed to both entering and exiting X-rays. In proton therapy, skin exposure at the entrance point is higher, but tissues on the opposite side of the body to the tumor receive no radiation. Thus, X-ray therapy causes slightly less damage to the skin and surface tissues, and proton therapy causes less damage to deeper tissues in front and beyond the target. Physicians base the decision to use surgery or proton therapy or any radiation therapy on the tumor type, stage, and location. In some instances, surgery is superior, and in others, radiation is superior. In some situations, they are comparable, which may result in them both being used together. Historically, proton therapy has been expensive. The relative cost of proton therapy is approximately 2.4 times that of X-ray therapies. However, newer, more compact proton beam sources can be 4 to 5 times cheaper and offer more accurate three-dimensional targeting. Thus, the cost is expected to reduce as better proton technology becomes more widely available. As of August 2013, 43 particle therapy facilities worldwide represented a total of 121 treatment rooms available to patients. Of these, 28% are located in the US, 23% are located in Japan, and more than 96,537 patients had been treated. The figure below shows the proton treatment centers in the United States. These are my references. Thanks for watching.